Welcome back. So we are learning about the circuit analysis constituting of like series and parallel combinations. So another very important concept in this like topic is Y-delta transformation. Okay. So Y-delta is basically sometimes, okay, we have seen some earlier examples. Okay, you can watch the earlier videos where we try to find out the series like the equivalent resistance for such kind of circuits. So such kind of circuits was easy to analyze that we can easily distinguish like which branch is in series in parallel. But if we have a circuit like this one, it's hard to distinguish. It's hard to like uh, make a clear cut analysis like which resistor in series and parallel. For example, I know that this current I1 is coming. This will be divided into uh, current through R2. Let's call this I2 and current through R1, which is basically let's call this I3. So it means this R1 and R2 will be in parallel because the current is being divided. But if you look at the nodes, they are sharing only one node, okay? This second node is not common between them. Okay, so the parallel combination, the rule for the parallel is two nodes must be shared, but this second node is not shared. So the current is being divided. That gives us an idea that there could be in parallel, but the second node is not shared. So it means we cannot clearly say that they are in parallel. Same goes for R4 and R5. Okay, so this is basically make a circuit of a delta. Okay, so if you look at like the circuits, it's coming like making kind of a triangle here, which is called basically delta. Okay, so what we can do to analyze such circuits, we can transform them. Okay, so I can convert this kind of a delta to a Y shape. Okay, this is a kind of an inverted Y. Okay, so if we label the nodes like A, B, and C, so I can convert basically this parallel R2, okay, to a resistance which we call RA. Okay, so RA is basically the resistance between, okay, and similarly I can convert, okay, basically the combination of R1 and R3 to RC and RB. Okay, so if we like convert this delta to Y, this is delta to Y transformation. And if we draw the circuit, so our circuit will look like this one, okay, with this Y here. So if we have this circuit, now we can easily analyze that. How? We can easily say that RB and R5, they are sharing one node, okay, so they will be in series. Okay, RC and R4 again sharing one node, so they will be in series. Okay, so this will become one resistor, this become one resistor. Okay, then they will be in parallel, like this whole thing, that will be in parallel, then that will be in series with this R6. So our analysis will become easier for such cases. So the rule for the transformation is that we can say that the resistance between basically A and B, okay, nodes A and B, that will be basically the same like this resistor RA plus RB. Or we can say that basically resistance between point node A and B is basically the combination of R1 and R3, right? Like this R2 is basically parallel with series of R1 and R3. Okay, so using these assumptions, if we do the derivations, we can find out the relationships that actually help us to find out. So let's say like if you want to go from delta to Y, okay, like you know the values of R1, R2 and R3, so we can use basically this combination, this resistive formulas. Similarly, if you want to go from Y to delta, we can use this set of equations, okay, for the transformations. So labeling them like in delta, this is R1, R2 and R3. In Y, this is RA, RB and RC. Put up the numbers here and we can find the values. So this way we can do the transformations. So let's have a look at one examples of this application. So we have this circuit here. We want to find the IS. Okay. So we have a voltage source here. So easier way could be like if this is 12 volt, if let's I define this A and B, if I find the resistance which is coming between nodes A and B, I can easily find IS. So IS will be what? Voltage divided by that resistance value. Okay. Now how we can find that equivalent resistance value? We need to look at the circuit from the end of the point. So if you look at the end of the circuit, what we can see here? So we can see here, okay, like 6K, they are sharing one node, but this is also sharing a node with this one. 6 and 12K sharing one node, but the other node is not common between them. Okay, so it becomes hard to basically analyze this circuit as it is. But if you look closely, what we can see here, so we have basically a kind of a delta network here, right? Okay, so like this whole thing is basically kind of a delta. Like if we call this A, okay, and let's call, okay, this point B and this point C, okay, for the simplification. Well, you can use other variables also. So I have basically this 12K, I have this 18K, and then I have basically this 6 kilo, right? So this is kind of a delta. So we can convert this delta to the Y form. Okay, so what is the Y form? Inverted Y form. Like this is RA, this is RB, and this is RC. Okay, for the delta, this is our R1, this is our R2, and this is our R3. Okay, and we know the formulas. Okay, so these are our formulas for the conversion. So by using these formulas, for example, if I want to calculate the value of RA, so value of RA is basically R1 times R2 divided by R1 plus R2 plus R3. So if you plug in the values, what is of R1? 12K, R2 18K, and the sum 12 plus 18 plus 6. So if you simplify this, this comes out to be 6 kilo. Similarly, if you want to find RB, RB is R2 times R3, and then again sum of the resistors, okay? R1 plus R2 plus R3. Again, if you plug in the values, use your calculators, so the answers comes out to be 3 kilo. Okay, similarly RC, this is basically R3 times R1, again sum of the resistors. So this will give me basically a value of 2 kilo. So it means I can redraw my circuit. So if I redraw this circuit, how it will look like? Like we have a 12 volt here. So this is my point. Okay, so here I have this RA, here I have RC, and here I have RB. Okay, so basically this is node B and this is node C as per this. And then at this, what we have here, at node B, we have basically a 9 kilo ohm resistor. And here we have basically a simple 4 kilo ohm resistor. And this node is basically common between them. So we know the values of RA, RB, and RC. So let's just put them in the circuit. So value of RA is 6K, value of RB is 3K, value of RC is basically 2K. Now if you look at this circuit, what we can see here, this 9 and 3, they are in series. So 9 and 3 series, that will basically become 12, right? This 2 and this 4, they are in series. So 4 plus 2, 6. So basically I have a 12K here, okay, because of this. And I have a 6K here because of this. So 12 and 6, that will be in parallel. So 12 and 6 parallel, 12 times 6, about 12 plus 6. So that will give me basically what? 4 kilo, right? So it means I can get a new circuit here that I can draw like this one. Okay, this is basically 6K of RA, and then 12K parallel with this basically just simply become 4K. Okay, so this is my circuit. Now like I can find equivalent resistance, basically 6 plus 4, 10K. Okay, so what we can do here, we can easily find the value of basically current that will be basically flowing through this circuit now IS. So IS will basically what? 12 divided by equivalent resistance, which is 10K. So 12 divided by 10K, this is just simply 1.2 milliampere. So we solve this circuit using the Wye-Delta transformation. So we simplify our circuit, and after that we can get the more simplified version, and from that we can easily find the required voltage or currents. Thank you so much.